Hello, this video contains all content from the J277 OCR GCSE Computer Science Specification for Paper 1 Computer Systems. There is a separate playlist for each individual topic, but this video contains them all in one place and in under 90 minutes, which is the length of the paper. The purpose of the central processing unit is to process data instructions by constantly performing the fetch-execute cycle. In this cycle, instructions are fetched from RAM and transferred into the registers inside of the CPU. It is the memory data register specifically that instructions are stored in. In the execute stage of this cycle, instructions are decoded by the control unit and then executed. The ALU performs any arithmetic or logical calculations. The control unit sends control and timing signals to the ALU and other components like RAM to direct the operation of the CPU. It also manages the flow of data in the CPU and decodes instructions in the fetch-execute cycle. The arithmetic logic unit, ALU, performs mathematical calculations, logical operations, and binary shifts. The registers are temporary storage spaces for one piece of data or one address at a time. Specific registers are used in the FE cycle. Cache memory is used to temporarily store data that is frequently accessed. It is split into 3 levels and it is faster to access than RAM. The program counter stores the address of the next instruction to be fetched from RAM. The address from the program counter is copied into the memory address register. The program counter is then incremented by 1 because it always shows the address of the next instruction. The memory address register stores the address of the current instruction to be fetched from RAM once it has been copied from the program counter. The instruction or data is transferred from the RAM address identified in the memory address register and stored in the memory data register. The results of any executions, such as calculations made by the arithmetic logic unit, are stored in the accumulator. The program counter and memory address register are used in the fetch stage to store an address. The memory data register is also used in the fetch stage, but it stores data. In the execute stage, the accumulator stores data. The key feature of von Neumann architecture is that both data and program instructions are stored in the same format, which is binary, and in the same memory, which is RAM. Von Neumann architecture also uses these standard CPU components: the control unit, the ALU, the registers and cache memory, along with specific registers, the MAR, MDR, PC, and ACC, all used to constantly perform the fetch-execute cycle. All instructions to be processed by the CPU are split into 2 parts, the opcode and the operand. The control unit does this when decoding instructions in the fetch-execute cycle. The opcode is the action to perform, such as add, input, or load. The operand can refer to data, which is a value, or an address, which is a location in RAM. Clock speed is the measure of how many fetch-execute cycles the CPU can perform a second. Clock speed is measured in gigahertz. 1 gigahertz is 1 billion cycles per second. A typical desktop computer may have a clock speed of between 3 and 5 gigahertz. CPUs can be overclocked or underclocked to change their cycle rate from the default speed. A higher clock speed improves the performance of the CPU because more fetch-execute cycles can be processed per second. With more instructions processed per second, complex tasks can be completed at a faster rate. Cache memory is temporary storage inside the CPU for frequently accessed data. It is split into 3 levels, each level being larger but slower than the previous. As data and instructions are being fetched in the fetch-execute cycle, frequently required data can be stored in cache to save time by not having to transfer them repeatedly from RAM. A CPU with a larger amount of cache memory will be able to store more frequently accessed data. improving performance as the data can be accessed faster than fetching it from RAM. Some CPUs have multiple cores. A core is a complete set of CPU components, with a control unit, ALU, registers, and level 1 cache. Each core is able to perform its own fetch-execute cycle. A CPU with more cores should have a higher performance because it can process more instructions at the same time. But if a task requires one core to wait for another to finish, overall performance may not improve. Also, some older software is not written to use multiple cores, so it will not run faster with a multi-core CPU. An embedded system is built into a larger device such as a car or microwave to provide a means of control. It has limited functions and is used for specific repeated tasks. They often use a microprocessor on a single circuit board, unlike general-purpose computers like laptops and desktops that have a range of components. The operating system and software is built into the ROM. This is known as firmware. A washing machine has an embedded control chip that manages wash cycles and water temperature. Modern cars contain embedded systems too, to manage the engine system or automate lights. Primary storage is high-speed internal memory that the CPU can directly access. The main types are RAM and ROM. Memory is needed to store active data for the CPU to fetch and execute at high speeds. However, memory has a limited capacity compared to secondary storage like a hard disk drive. ROM is usually measured in megabytes, RAM in gigabytes, and hard drives in terabytes. Random access memory is volatile. This means that data is lost when the power is turned off. RAM temporarily stores the instructions and data for programs that are currently running. It also stores parts of the operating system. The contents of RAM can be changed. Data can be written to RAM and also read from it. Read-only memory is non-volatile. This means that data is saved even when the power is turned off. ROM stores the startup instructions, known as the bootstrap program, to load the operating system when a computer is switched on. It also stores the BIOS, which checks if the other components are functioning. ROM is read-only, meaning the contents cannot be changed and can only be viewed. Programs stored in ROM are called firmware. When RAM is close to full capacity, the hard drive or solid-state drive is used as an extension to RAM. This is known as virtual memory. Parts of programs that are not currently needed are moved to virtual memory on the hard drive. When required, the pages are moved from virtual memory back into RAM. Virtual memory allows more programs to be run at once without running out of memory space. However, using virtual memory too often will cause disk thrashing and slow the computer down. Secondary storage is used for the long-term storage of files and data because it is non-volatile, meaning the data is saved even when the device's power is turned off. Secondary storage also has a much higher capacity than primary storage, up to several terabytes of data for some devices like a hard disk drive. The three types of secondary storage are magnetic, optical, and solid state. One way to remember the 6 characteristics of secondary storage is using the CSNU's mnemonic PC card. Portability relates to moving a storage device between locations. Small devices are easy to transport from one location to another in a bag or even a pocket. Capacity is the maximum amount of data that can be stored. Traditionally, this was measured in gigabytes, but many modern devices use terabytes. The price of storage devices can be compared per gigabyte. For example, a hard disk drive is often less than 1 penny per gigabyte. Access speed is how quickly data on a secondary storage device can be written to or read from. Devices without moving parts are the fastest to access data. A reliable storage device will last for several years without failing or having major data corruption. A durable storage device is physically strong and can be transported without breaking. Optical storage is quickly becoming obsolete due to its inferior characteristics compared to magnetic and solid-state storage. All three main types of optical disks have low capacities. Standard CDs can store 700 megabytes, standard DVDs can store 4.7 gigabytes, and a standard Blu-ray disc can store 25 gigabytes. Discs are cheap to manufacture, making them ideal for mass-producing music albums, movies, or games. They are lightweight and portable, but they need to be protected. Despite a single disk being cheap, optical storage is the most expensive per gigabyte and has a very low capacity. 700 megabytes for a CD means it's roughly 28 pence per gigabyte. Optical disk drives use a laser to beam light onto a spinning disk. The moving disk means the access speed is slow, and the disk can be easily scratched and degrade over time. Magnetic storage is still a popular type of secondary storage, with a high capacity and low price per gigabyte. The most common type of magnetic storage is a hard disk drive. This uses a read-write head to move across tiny individual sections of a magnetized spinning disk. A hard disk drive can be internal or external. Older types of magnetic storage include magnetic tape, which is sometimes still used for backup, and floppy disks, which are not used because it had a very low capacity. Magnetic hard drives have a very large capacity, often several terabytes in size. Of the three types of secondary storage, magnetic storage is the cheapest per gigabyte to purchase, usually less than 1 penny per gigabyte. Because of a moving magnetized disk, it is slower to access data than solid state, and both less reliable and durable because the disk mechanism will eventually fail. Magnetic storage is still better than optical for access speed, reliability, and durability. External hard drives are heavier but much more durable than optical disks, making them arguably a more portable option. Solid-state storage is quickly becoming the most popular type of secondary storage due to its superior characteristics. Solid-state storage such as solid-state drives, USB sticks, and SD cards contain no moving parts, meaning that data can be directly accessed at very high speed. Solid-state drives can be internal or external, USB sticks are highly portable, and SD cards and micro SD cards are used in devices like cameras and smartphones. Because they contain no moving parts, solid-state storage has the fastest access speed. This also means they are small, highly portable, reliable over many years, and durable. Solid-state storage devices like solid-state drives have a large capacity and are becoming cheaper, but hard disk drives are still less expensive per gigabyte and they have more storage space. A USB stick will roughly cost between 5 and 10 pence per gigabyte. All data is stored in binary because computer systems consist of billions of tiny transistors which act as switches. These switches have two states, on, which is represented as 1, and off, which is represented as 0. A single binary digit is called a bit. 4 bits are called a nibble. 8 bits are known as a byte. There is a difference of 1000 between the data storage units. For example, 1000 bytes is 1 kilobyte, or 1000 kilobytes is 1 megabyte. You may have seen a difference of 1024 in other resources, but this is technically a different number system, which uses kibibytes, mebibytes, gibibytes, and tebibytes. You can use this in an exam, but remember that calculators are not allowed, so it is simpler to use the difference of 1000. Each character on a keyboard is typically stored in 1 or 2 bytes. Text documents without pictures, like Kindle books, are measured in kilobytes. Songs and images usually take up a few megabytes each. Software like video games can take up several gigabytes. Movies maybe just a few gigabytes. Secondary storage like hard disk drives and solid-state drives are now measured often in terabytes. Only global organizations like Google, Meta, or Microsoft would use petabytes. 1 petabyte can store roughly 250 million images or 1 million hours of video. To To calculate how many files can be stored on a device with a specific capacity, the file size and capacity must use the same units of measurement. Here is a reminder of the key measurements you need to know. You must divide by 1000 when converting to a larger data unit. For example, 100 gigabytes divided by 1000 would give you the equivalent in terabytes, which is 0.1. You must multiply by 1000 when converting to a smaller data unit. For example, 25 megabytes multiplied by 1000 would give you 25,000 kilobytes. Here is an example. Josh has 500 megabytes of free space on his USB stick. Each image he wants to store is 650 kilobytes. How many images can he store? We need to convert the 500 megabytes into kilobytes so that we can accurately compare them. 500 megabytes we multiply by 1000 to turn it into 500,000 kilobytes. 500,000 kilobytes divided by 650 kilobytes gives 769.2. We cannot have 0.2 of an image, so we round it down to 769. In an exam, you cannot use a calculator, so the questions should be a little bit simpler than this. We also could have done it the other way and converted the kilobytes into megabytes by dividing by 1000. Sometimes it is necessary to move between multiple data units. As an example, let's work out what 340,000 kilobytes is in gigabytes. First, we need to convert the kilobytes into megabytes by dividing by 1000 to give us 340 megabytes. Now we need to divide by 1000 again to turn it into gigabytes. The 340 megabytes is converted into 0.34 gigabytes. All data is stored in binary because computer systems consist of billions of tiny transistors which act as switches with only two states, on represented by 1 and off represented by 0. Number systems can be identified by their base, which refers to the number of unique digits that can be represented. Binary is a base 2 number system consisting of only two values, 0 and 1. The base also refers to the difference in place values. In binary, each place is a power of 2. The bit furthest to the right of a binary number is called the least significant bit. This represents the smallest binary value in the number, which will always represent 1. The bit furthest to the left of a binary number is called the most significant bit. This represents the largest binary value in the number. With an 8-bit number, the most significant bit will represent 128. Denary, also known as decimal, is a base 10 number system. The 10 digits are 0 to 9. Each place is a power of 10. Hexadecimal is a base 16 number system. The digits are 0 to 9 and then A to F. Each hexadecimal digit represents 4 bits, which is a nibble. See how 10 is replaced by A, 11 by B, 12 by C, 13 by D, 14 by E, and 15 is replaced by the letter F. Because hexadecimal uses fewer digits to represent the same number in binary, it is easier to read and write with. There's also a lower likelihood of making mistakes. For example, 8C9E uses just 4 digits, which would require 16 digits to write in binary. Here is a summary of the 3 number systems. Binary uses 2 digits, 0 and 1. The range in 8 bits is from 0000, 0000 to 11111111. Denary uses 10 digits, 0 to 9, and the range in the same equivalent 8 bits would be 0 to 255. Hexadecimal uses 16 digits, 0 to 9, and then A to F. The range would be from 00 to FF. It is important to understand the relationship between the number of bits and the equivalent total, lowest, and highest denary values that can be represented. For example, with just 1 bit, you have 2 possible values, a low of 0 and a high of 1. With 2 bits, you've got 4 possible values, a low of 0 and a high of 3. Do not be tricked. The lowest denary value that can be represented by any number of bits that is always 0. And the highest denary value is the total number of values take away 1. For example, with 8 bits, you can represent 256 different numbers. the lowest being 0 and the highest being 255. Neatly write out the binary number. Write the binary place values from right to left. They increase by the power of 2 with each place, from 1 up to 128 with an 8-bit number, doubling each time. Add together all the place values that have a 1 beneath the number. So 128 plus 32 plus 16 plus 4 plus 2. Adding those values together gives 182. So 10110110 is equivalent to 182. Binary numbers in exams will usually be shown to you in 8 bits, but it might not be. Make sure that you write the place values from right to left, starting at 1, rather than left to right, starting at 128, so that you don't make any errors. Don't panic if a binary number is shown in an exam with less than 8 bits. You can fill in any missing values with zeros and it will be the same number. So 101011 is the same as 00101011. Write out the binary place values from right to left. They increase by the power of 2 with each place. So for an 8-bit number, it starts at 1 and doubles each time to 128. This example will convert 91 into binary. Starting from the left, you will see if a place value fits into the denary number. If it does, we write a 1 and subtract the place value. Otherwise, we will write 0. The place value of 128 does not fit into 91, so we will add a 0 beneath 128. 64 does fit into 91, so we put a 1 below the 64 place value. Now that we've written a 1, we must subtract that place value from the denary number. 91 take away 64 gives us 27, which is the new value that we will compare to the place values. 32 does not fit inside of 27, so we write a 0 below the 32 place value. 16 does fit inside of 27, so we write a 1 below the 16 place value. We subtract 16 from 27 to make a new denary number of 11. 8 fits into 11, so we write a 1 below 8. We subtract 8 from 11 to make 3. 4 does not fit into 3, so we write a 0 beneath the 4 place value. 2 fits into 3 and a 1 is written below the 2 place value. 2 is subtracted from 3 to make the new denary value of 1. 1 fits into 1, so we place a 1 below the 1 place value. Subtracting 1 from 1 makes 0, completing the entire conversion. So 91 is the same as 01011011. Here is another example, converting 44 from denary into binary. 128 does not fit into 44, so we put a 0. 64 is also too large for 44, so again we put a 0. 32 does fit into 44, so we add a 1 beneath the 32 place value and subtract 32 from 44, giving us 12. 16 does not fit inside of 12, so we put a 0 beneath the 16 place value. 8 does fit inside of 12, so we add a 1 beneath the 8 place value and subtract 8 from 12, giving us 4. 4 fits inside of 4, so we add a 1 beneath the 4 place value and subtract 4 from 4, giving us 0. Now that our denary number is 0, we can add 0 to the rest of the place values. The final conversion is complete, and 44 is equal to 00101100. Clearly write out the binary number to be converted into hexadecimal. Hexadecimal represents 16 values, 0 to 9, and then A to F. 10 to 15 are replaced by letters. Hexadecimal works with nibbles, which are groups of 4 bits. The place values are written from right to left, from 1 to 8. Now work out the hexadecimal value of each nibble by adding together the place values with a 1 beneath them. The left or most significant nibble is equal to 7, because 4 plus 2 plus 1 is 7. The right, or least significant nibble, is equal to A. 8 plus 2 is 10, and 10 is replaced by A. The final answer for this conversion of 01111010 is 7A. 2 hexadecimal digits are used to represent an 8-bit binary value. Be aware that this could be a number and a letter and a number, or 2 numbers or 2 letters. Hexadecimal works with nibbles, which are groups of 4 bits. The place values are written right to left, from 1 to 8. Hexadecimal represents 16 values, 0 to 9, and then A to F. 10 to 15 are replaced by letters. This example will convert 5C from hexadecimal to binary. 5 is made by adding 4 and 1. Write a 1 beneath those 2 place values. C is equivalent to 12. 12 is made by adding 8 and 4. Write a 1 below those place values and a 0 below any of the other place values which have not been used. The final conversion of 5C into binary is 01011100. 2 hexadecimal digits are used to represent an 8-bit binary value. Be aware that this can be a number and a letter and a number, or 2 letters or 2 numbers, like the examples here. To convert from denary to hexadecimal, it is easier to convert the number into binary first. Write the binary place values from right to left, from 1 to 128 for an 8-bit number. Starting from the left, see if the place value fits into the denary number. If it does, write 1 and subtract the place value, otherwise write 0. 128 does not fit into 76, so 0 has been written below the 128 place value. 64 does fit into 76, so put a 1 below the 64 place value. When a 1 is written, that place value is subtracted from the denary number, so 76 take away 64 gives the new denary number of 12. 32 does not fit into 12, so 0 is written below the 32 place value. 16 does not fit into 12 either, so 0 is written below the 16 place value. 8 does fit into 12, so 1 is written below the 8 place value, and 8 is subtracted from 12 to make the new denary number 4. 4 fits into 4, 1 is written below the 4 place value, 4 is subtracted by 4 to make the new denary value 0. Both 2 and 1 do not fit into 0, so a 0 is written beneath the 2 place values. 76 has now been converted into binary. To convert the number into hexadecimal, the place values need to be changed from a single byte to 2 separate nibbles, with 1248, 1248 as the place values. Hexadecimal represents 16 values, 0 to 9, and then A to F. 10 to 15 are replaced by letters. Add together the place values that have a 1 beneath them. For the left nibble, it is just 4. The right nibble is equal to 12, 8 plus 4. 12 in hexadecimal is equivalent to the letter C. The final conversion is now complete. 76 was converted into binary to make 01001100. This was then converted into hexadecimal to give 4C. Converting a denary number into hexadecimal by converting it first into binary is a valid method in an exam of making the switch between those 2 number systems. However, there is an alternative method which allows you to convert directly from denary into hexadecimal, as long as you know the 16 times table and have an understanding of both integer division and modulo division, which are topics from paper 2. To work out the left nibble, you would need to use integer division. For example, 76 integer division 16 gives you 4, as that is a whole number when 76 is divided by 16. To work out the right nibble, you would need to do the denary number, 76, and then modulo division, 16. 16 goes into 76 4 times. 16, 32, 48, and 64. Modulo division works out the remainder from that 64 to the original value of 76, which is a remainder of 12. 12 in hexadecimal is C. Hexadecimal represents 16 values, 0 to 9, then A to F. 10 to 15 are replaced by letters. This example will convert C7 from hexadecimal into denary. To convert from hexadecimal to denary, the traditional method is to convert the number into binary first. Write the place values out for two nibbles, right to left, 1 to 8 and 1 to 8. C is equivalent in hexadecimal to 12. 8 plus 4 is equal to 12, so 1 is written beneath the 8 and the 4 place values, and a 0 beneath the other two. 7 is equal to 4 plus 2 plus 1, so 1 is written beneath those place values, and a 0 beneath the other one. C7 has now been converted into binary. To convert into denary, the place values need to be changed from two separate nibbles into a single byte, with the place values from 1 to 128, right to left. Now add together all the place values that have a 1 beneath them. 128 plus 64 plus 4 plus 2 plus 1. This gives 199, and C7 has now been converted into 199 via a binary conversion first. There is an alternative method which allows you to convert directly from hexadecimal into denary. You multiply the left nibble by 16 and then add the value of the right nibble. So for 7e, 7 times 16 gives 112. E is equal to 14, so you add 14 to 112 to make 126. In the second example, b is equal to 11, so 11 times 16 gives 176, and then add 4 for a final answer of 180. Binary addition can be used to add together two binary values without needing to convert them into denary. There are four possible combinations to know. 0 plus 0 is clearly 0. 1 plus 0, or 0 plus 1, is equal to 1. 1 plus 1 is obviously 2, but in binary, this is represented as 1, 0. The 1 is a remainder, known as a carry, and then the 0 is the normal number. This will make more sense in the example shortly. 1 plus 1 plus 1 is 3. 3 in binary is 1, 1. Write the two binary values that you're going to add together neatly on top of each other. Binary addition works from right to left. 0 plus 0 is 0, and this value is written below the other two binary values. In the next column, 0 plus 1 is equal to 1. 1 plus 1 is 2. In binary, 2 is written as 1, 0. The 1 is placed as a carry in the next column, and the 0 is written below. This column now reads as 1 plus 0 plus 0, which is equal to 1. 1 plus 1 is 2. Remember that is 1, 0, so the 1 becomes a carry, and a 0 is written below. This column now reads as 1 plus 0 plus 1, which is 2, making 1, 0. The carry is added to the next column, and a 0 is written below. 1 plus 1 plus 1 is 3, which in binary is represented as 1, 1. 1 is added as a carry to the next column, and the other 1 is written below. The final column is 1 plus 0 plus 0, which gives 1. Just as a note, for full marks in an exam, it is important to show that you haven't just converted them to denary and added them together. So showing the carries is usually 1 mark, and having the correct final answer is usually a 2nd mark. An overflow error occurs when the result of binary addition exceeds the maximum value that can be stored in the number of bits. For an 8-bit value, this is anything larger than 255. An overflow error will occur if there is a carry on the calculation of a most significant bit. Overflow errors will produce an incorrect result. In this example, 156 plus 214 should give 370, but there is an overflow error which is resulting in 114. Binary shifts can be used to multiply or divide binary numbers by multiples of 2. In this example below, a left shift of one place has occurred to change 21 into 42 by moving all of the values one place to the left, doubling the number. Shifting a binary number to the left will multiply it. Shifting a binary number to the right will divide it. For every place that is shifted, the effect doubles. In this example, 21 is the original number. This is then shifted one place to the left to multiply it by 2 to make 42. 2 places to the left has an effect of multiplying it by 4 to make 84. And shifting it 3 places to the left has an effect of 8, multiplying it by 8 to make 168. As an example, we will perform a right shift of 2 places on 11010100 and state the effect that has taken place. Each binary value needs to be shifted 2 places to the right, so the 1 in the 128 column moves into the 32 column. The 1 in the 64 column is moved over to the 16 column. This continues for the other values in the number, each being shifted 2 places to the right. By shifting 2 places to the right, that means the 2 values on the far right-hand side will be dropped off, and these values can be ignored. Zeros are always written in any new spaces that have been created by a shift, even if they are replacing ones. A right shift divides, and a shift of 2 places has an effect of 4. Therefore, the overall effect of this shift is dividing by 4. 212 has been divided by 4 to make 53. A binary left shift may result in an overflow error if the result of the shift is more than the maximum value that can be stored in the number of bits. This is 255 for an 8-bit value. Shifting left with a 1 in the most significant bit will cause an overflow error. In the example below, 181 has been shifted 1 place to the left. This should have given 362, but an overflow error has occurred, resulting in an answer of 106. A binary right shift could result in a loss of precision when dividing odd numbers because a standard byte cannot store a decimal number. Shifting right with a 1 in the least significant bit will give an inaccurate result. In the example below, 51 has been shifted 1 place to the right, which should divide the number by 2 and give 25.5. However, the result is shown as 25, with a loss of precision of 0.5. A character set is a collection of all the characters a computer can represent. A table maps or matches each character to a unique binary code. Here's an extract of the ASCII character set. You do not need to memorize any characters or their binary equivalents. Character sets are essential for exchanging data and inputting text. Characters mapped by a character set include letters, numbers, symbols, control characters like backspace and tab, and in some sets, emojis. In this example, the word morning and an exclamation mark have been converted into binary using the ASCII character set. Character sets are logically ordered. For example, if E was equal to 101, F would be 102, G would be 103, and so on. Character sets have different values for lowercase and uppercase letters, and a blank space is also a character. ASCII stands for American Standard Code for Information Interchange. ASCII is a character set that is used to map characters to unique binary values. ASCII uses 1 byte, which is 8 bits, to represent each character. This means that ASCII can represent a total of 256 different characters. An advantage of ASCII is that because it only uses 1 byte per character, it uses less memory space than other character sets like Unicode, which uses 2 bytes per character. In this example, Apple would be represented in 5 bytes by ASCII, but in 10 bytes by Unicode. A disadvantage of ASCII is that it only uses 1 byte, which allows for 256 possible characters. This is enough for some languages like English and most of Spanish or German, but it can't be used for all other languages and all symbols. It is important to know that in reality, ASCII actually uses 7 bits to represent 128 characters, and a version of ASCII called Extended ASCII uses 8 bits for 256 characters. However, the OCR GCSE J277 specification simplifies ASCII to meaning 8 bits for 256 characters, which is what will be expected in the exam. Unicode is a character set that is used to map characters to unique binary values. It is the most popular character set because it can represent thousands of characters. In this example here, May 25th has been converted using Unicode and represented in hexadecimal. Unicode uses 2 bytes, which is 16 bits, to represent each character. This allows for 65,536 possible characters. In the extract of a Unicode character set table here, you can see 5 different characters, with their binary, denary, and hexadecimal equivalents, none of which you need to memorize for any exam. An advantage of Unicode is that having an extra byte over ASCII allows many more characters to be represented. This includes all languages and thousands of symbols and emojis. A disadvantage of Unicode is that it requires more memory to store each character than ASCII, as it uses 2 bytes instead of ASCII's 1. In this example, the term oak tree, including the space between the 2 words, would be represented in 8 bytes in ASCII, but 16 bytes in Unicode. Unicode is backwards compatible with ASCII because the first 128 Unicode values match the first 128 ASCII values too. So capital H in this example would be represented using the same values in both character sets. The file size of a text file is calculated by multiplying the bits per character by the number of characters. As a reminder, ASCII uses 8 bits per character and Unicode uses 16 bits per character. As an example, let's say a small text file has 250 characters and uses the ASCII character set. You would do 8 multiplied by 250 to give you 2000 bits. Some exam questions may ask you to provide your answer in bytes or kilobytes. To turn bits into bytes, divide by 8, such as 2000 bits, divided by 8 to become 250 bytes. Once your answer is in bytes, divide by 1000 to turn it into kilobytes. For example, 250 bytes is the same as 0.25 kilobytes. Let's look at another example. A text file uses the Unicode character set and contains 335 characters. What is the file size in bytes? Unicode uses 16 bits per character, so 16 multiplied by the number of characters, which is 335, to give 5,680 bits. Divide this by 8 to give your answer in bytes, which is 710. Most computer images are bitmaps, which use a series of square blocks called pixels arranged on a grid. Vectors are another image type that follow precise mathematical instructions instead of using pixels, but you do not need to know about vectors for the exam. Each pixel is given a binary code, which represents the color of that pixel. Each color has a unique binary code. The resolution is the total number of pixels in an image. Resolution is calculated by the width times the height in pixels. In this example, the width is 5 pixels and the height is 6 pixels, giving 30 pixels in total. The resolution affects image quality and file size. The higher the resolution, the better the image quality, because there are more pixels available to display a clearer image. The higher the resolution, the larger the file size, as there will be more pixels and each pixel is represented by binary values which need to be stored. The color depth is the number of bits that are used to represent each pixel's color. It is the number of bits, not the number of colors. So a color depth of 4 would be 4 bits, giving 16 possible colors. In a byte, which is 8 bits, you can have 256 different possible colors. Images with a larger color depth will have an improved image quality, although the file size will be larger as there are more bits per pixel. The number of colors that can be represented will increase. Metadata is additional data about a file to provide further context. For images, metadata can include the height, width, color depth, resolution, geolocation, the date it was created, the date it was last edited, file type, file name, and many more. To calculate the file size of an image file, it is the resolution multiplied by the color depth. Let's look at an example. An image has a width of 120 pixels and a height of 210 pixels. It has a color depth of 6 bits. What's the file size in kilobytes? First, work out the resolution by multiplying the width and height of the image in pixels. That's 120 times by 210 to give 25,200. Now we can multiply that number by the color depth, which is 6 bits, to give 151,200 bits. Remember that an exam will not allow you to use a calculator, so the calculation should be a bit easier. Now that the answer is in bits, we need to divide it by 8 to convert it into bytes, which is 18,900. Dividing the bytes by 1000 will give you the equivalent in kilobytes, which is 18.9. Analog sound waves must be digitally recorded and stored in binary. To sample the sound, the amplitude or height of the analog sound wave is measured and recorded in binary at specific intervals. The sample rate is how many times per second the amplitude of a sound wave is measured. The sample rate is measured in hertz. 44.1 kHz or 44,100 Hz is the standard sample rate of a CD or a standard music application like Spotify. A higher sample rate will increase the audio quality as it will more accurately represent the original sound wave. The file size, however, will increase as a binary value is recorded for each sample and more samples will be stored. The bit depth of an audio file is the number of bits available to represent each sample. It can be considered as representing the range of amplitude values or unique sounds available for each sample. The range of possible amplitudes that can be recorded is doubled with each bit added to the bit depth. So 1 bit gives 2 possible amplitudes, 2 bit 4 possible amplitudes. You can see that a range of 16 sounds is available for 4 bits, from 0000 to 1111. With a bit depth of 8, that gives you a range of 256 different sounds. The higher the bit depth, the more bits are available to be used, and therefore the audio quality is clearer and more accurate. However, the file size will also be larger if the bit depth is higher, as each sample stores additional bits. To calculate the file size of a sound file, it is the sample rate multiplied by the bit depth multiplied by the duration. Let's look at an example. A sound file has a sample rate of 40 Hz and a bit depth of 6 bits. It lasts for 12 seconds. Give the answer in kilobytes. 40 multiplied by 6 gives 240 bits per second. Multiplying 240 by the 12 seconds gives 2880 for the whole sound file in bits. To convert from bits to bytes, you divide by 8. 2880 divided by 8 gives 360 bytes. To convert from bytes to kilobytes, it's a division of 1000. 360 bytes divided by 1000 gives a final answer of 0.36 kilobytes. Compression is the use of an algorithm to reduce the size of a file. Benefits include that a compressed file will take up less storage space, so more files can be stored. Also, files can be transferred, such as being uploaded or downloaded, faster if they are of a smaller size. Some applications, such as email services, may have file size limits, and compression can help reduce file sizes to stay within these limits. Compressed files on a web page will result in faster loading times and less strain on servers and networks. Therefore, websites will have a better performance, especially for mobile users or slow connections. Lossy compression will decrease the file size by permanently removing data. The original file can never be fully restored. This may result in a noticeable loss of quality. Lossy compression can reduce the file size of an image by decreasing the color depth or its resolution. An audio file can be compressed by removing very high or low frequencies that humans cannot hear. An advantage of lossy compression is that it will result in a smaller file size than lossless compression, saving storage space and transferring files faster. Lossy compression works well for media files, such as images, audio, and video, where perfect accuracy may not always be needed. A disadvantage of lossy compression is that data is permanently removed, and the original file cannot be fully restored. Removing data may lead to a noticeable loss in quality. Another disadvantage is that it is unsuitable for certain files like text or software, as it would be incomprehensible if data was permanently removed. Lossless compression reduces the size of a file without permanently removing any data. When decompressed, the file is returned to its original form, so no quality is lost. An advantage of lossless compression is that there is no permanent loss of data, so the original file is fully restored. It can be recompressed any number of times without any reduction in quality. Lossless compression is essential for files that would be incomprehensible if data was permanently removed, such as text files and software like video games. A disadvantage of lossless compression is that as there is no permanent reduction of data, files will be larger in size than if lossy compression was used. Another disadvantage of lossless compression is that it takes longer to compress or decompress a file than lossy compression does. This is because it uses more complex algorithms, which you do not need to know for the GCSE. A network is a set of computers connected together to share data and resources, such as files, software, and hardware. This connection can be wired or wireless. A local area network connects computer systems that are situated geographically close together. A local area network is usually within the same building or small site, such as a house, school, or office. The infrastructure of a local area network is usually privately owned and managed by the people using the network. Data transfer speeds are often faster on a LAN as there is a smaller distance for the data to travel. A wide area network contains computer systems situated geographically distant to each other, possibly across a country or even the entire world. The Internet is an example of a wide area network. The infrastructure of a wide area network is usually not managed by a single group, and ownership is often shared between Internet service providers. Data transfer speeds are often slower on a WAN because the data has a further distance to travel. There are many reasons why a network may suffer performance issues, including each of the bullet points below, which will be examined in this video. Bandwidth is the amount of data that can be transmitted per second, and it is usually measured in megabits per second or gigabits per second. A higher bandwidth improves network performance as more data can be sent at once. Higher numbers of users or devices sharing the same network can slow down transfer speeds due to congestion. Latency is the delay in the transmission of data, often caused by distance or network congestion. A lower latency improves responsiveness, and it is measured in milliseconds. Wireless networks can be affected by other electronic devices or physical obstacles like thick walls. Wired network cables can suffer from electromagnetic interference. Transferring large amounts of data over long distances will take more time. The signal strength and range of a wireless network can also affect performance. When packets of data are sent at the exact same time along the same connection, they may collide. The more data collisions on a network, the slower it will perform, as the data will need to be resent. Finally, a web server may perform poorly if it is overloaded by too many requests, maybe from a large number of users, or maybe from a DDoS attack. The server may also have limited resources, such as a low CPU speed or little RAM. The Internet is a global connection of computer networks. It uses servers to store and present websites, emails, and files to client devices when requested. Web servers display web pages to the client when their browser requests it. File servers store files and allow clients to retrieve them when requested. Printer servers queue print jobs that clients request and send documents to the correct printer. Email servers filter spam and send and store emails so they can be retrieved by clients when requested. A website and its files must be stored on a web server so that others can access them on the Internet. This is called web hosting. A domain name must be registered with an Internet registrar to ensure that it is unique. The domain is then added to the domain name system, which maps it to an IP address for access on a web browser. For more information, see the DNS video. Clients make requests to a central server for data or resources. The server processes the request and returns a response. An advantage of client-server networks is that data, security, and updates can be managed from a single location, making administration and backup easier. Another advantage is that servers are powerful systems that can process many requests simultaneously. These networks are scalable by connecting more clients or upgrading the server. A disadvantage of client-server networks is that installing and managing a server is an expensive process, and it may require skilled IT staff to initially configure the server and then maintain it. Another disadvantage is that all clients will rely on the server. If the server fails, clients cannot access any of its resources. Any issues with the server will affect all connected clients. There is no central server in a peer-to-peer network. Each computer is equal and responsible for its own security, backups, and data sharing. Peer-to-peer networks are often used in small offices or houses because servers are expensive and unnecessary for small, unspecialized networks. Computers communicate directly, making it ideal for quickly sharing files. An advantage of a peer-to-peer network is that it is a simpler and less expensive network to set up because no server is required. It is useful for directly sharing files between systems. Unlike in a client-server network, other systems here are not dependent on a single server. A single computer failing would not disrupt the whole network. However, without a dedicated server, there is no device to centrally manage security, file access, or backups. Because of this, performance may be slower. Another disadvantage is that managing a peer-to-peer network is more difficult and it doesn't scale as well. The more computers connected, the slower the network will perform. A wireless access point provides a link between wired and wireless networks. It creates a wireless local area network using radio waves that allows Wi-Fi enabled devices to connect to a wired network. A router directs data packets between different networks, such as a home local area network and the internet. Routers receive data packets and use a routing table containing IP addresses to determine the best route to forward the packets on. A switch connects devices on a LAN. It receives data packets from a connected system and forwards it directly to the correct device using its unique MAC address. MAC addresses of devices connected to the switch are stored in a table. A network interface controller, formerly called a network interface card, is an internal piece of hardware required for a device to connect to a network. Routers and other network hardware also require a network interface controller. Transmission media refers to the physical or wireless methods used to transfer data between devices on a network. See the video about wired and wireless networks for more information on this. Web pages are stored on web servers. Each web server has an IP address. It's much easier to remember a catchy domain name, like CSNoobs, than an IP address, so we need something to match domain names and IPs. The domain name system, DNS, uses servers to match domain names to IP addresses, so that web browsers can locate, request, and access web pages. The DNS process starts when a domain name, or URL, such as csnoobs.com, is typed into the address bar of a web browser. A request is sent to the local DNS server for the corresponding IP address of a domain name. The server has a list of domain names and their matching IP addresses. The DNS server checks if it holds an IP address corresponding to that domain name. If it does, it passes the IP address to the web browser. The browser connects to the IP address of the web server storing the web page to access and display it. There is a hierarchy of DNS servers. If an IP match is not found on the local server, the request is passed on to higher level servers. If it is found, it's passed down to lower servers and then returned. No match, such as a spelling mistake, will result in a DNS error. The cloud is a network of servers accessed on the internet to provide services. Cloud computing is an example of remote service provision, where tasks such as running applications or processing and storing data are done online and in a different physical location to the user. Google Drive and Apple's iCloud are two popular examples of cloud storage providers. Files are stored remotely and not locally, for example on the user's device, and require an internet connection to be accessed. Advantages of the cloud include that data can be accessed from any device with a stable internet connection. Also, multiple users can collaborate by accessing and editing files in real time. Cloud providers often offer automated backups and disaster recovery tools. Storage capacity is scalable, meaning it can be easily increased or decreased as needed. There is less need for a lot of local storage, freeing up physical space. And finally, there may be automatic updates, such as security fixes. Disadvantages of the cloud include that a stable internet connection is required to access data, and any network errors may make files inaccessible. Also, uploading and downloading large files can be slow depending on the bandwidth available. Cloud storage often has subscription fees, which may be more expensive long-term than local storage. Data is also stored on third-party servers, raising concerns about security breaches. Data must be transferred across networks, increasing the risk of interception. Finally, users depend on the cloud provider, and data could be lost permanently with server failure or if a company shuts down. Network topology refers to the layout of computer systems, known as nodes, on a network. A star network topology has all nodes connected to a central switch. Data is sent to the switch in the center of a network, which uses the unique MAC address of each device to send the data directly to its destination. Star topologies could also use a hub, which is an outdated piece of network hardware which receives a copy of the data packets and sends that copy to every connected device, which is much more inefficient than using a switch. An advantage of a star topology is that the switch can monitor and control transmissions on the network. Also, it is easy to add new nodes to the network via a direct connection to the switch. Star topologies are reliable because if one connection or node fails, the rest of the network will not be affected. Data transfer speeds are also generally fast due to fewer data collisions. Disadvantages of a star topology include that extra hardware, which is the switch, is required to be purchased, installed and maintained. Also, if the switch fails, the whole network will be unusable until the error is fixed. Network topology refers to the layout of computer systems, known as nodes, on a network. A mesh network topology has nodes connected to all or most other nodes. Data packets are transferred to the destination address along the quickest path, traveling directly if possible. An advantage of a mesh topology is that it is reliable, as if a path fails, data can take an alternative route to the destination. One node failing will not affect the rest of the network. Because of the many nodes and connections, a mesh topology can usually withstand large amounts of data traffic. Direct data transfer can also reduce delay. Disadvantages of a mesh topology include that it can be expensive to install and maintain because of the large amount of cables required, especially in a wired full mesh topology. Without a central device like a switch, and with hundreds of potential connections, wired mesh topologies can be difficult to manage and take up a lot of physical space. A wired network transfers data across a physical connection using transmission media such as Ethernet cables. A network interface controller is required within each device. Ethernet cables are used on local area networks to transfer data at high speeds, up to 10 gigabits per second, over short distance, such as when connecting computers to a switch or router. Ethernet is the only wired connection mode mentioned in the J277 specification, but fiber optic cables, which you can see here, and coaxial cables are two other popular types of wired connection. An advantage of using a wired connection is that there is a faster data transfer rate than wireless networks, especially local area networks using Ethernet cables. A lower latency means there is less delay when transferring data. Wired connections are more reliable, with less interference and a more stable connection. Also, security is better as physical access is needed to intercept data, unlike the wireless signals in a wireless network. However, wired networks restrict movement as devices are physically limited by cables. This can be inconvenient or even dangerous in busy environments where cables can be trip hazards. Setting up a wired network can be difficult, time-consuming, and will require ongoing maintenance. Finally, there will be additional costs for a wired network, requiring cables and devices such as switches to be bought. A wireless connection uses radio waves to transmit data through the air. Two common wireless connection modes are Wi-Fi and Bluetooth. Wi-Fi is used with wireless access points to connect multiple network-enabled wireless devices to a network, such as the Internet. Wi-Fi can transfer data faster and across a larger range than Bluetooth. Bluetooth is slower and has a much shorter range, usually less than 10 meters. It requires two devices to be directly connected or paired. It is suitable for ad hoc, which means temporary, connections. Wireless networks allow users to move freely within the coverage area without being restricted by cables. It is convenient and easy to set up and to connect new devices, even in outdoor locations. These networks are scalable, allowing many connected devices without the disruption of installing more cables. Some devices, like phones, cannot be physically connected to a network, so we'd have to use a wireless connection. However, they typically provide slower data transfer speeds and have a higher latency. They are less secure, and wireless signals can be more easily intercepted than wired connections. Also, they are more likely to suffer interference from walls or other devices and networks, lowering the performance. Finally, they have a limited coverage area, with decreasing signal strength the further from the wireless access point. Encryption is the process of scrambling data into an unreadable format so that attackers cannot understand it if intercepted during transmission. Encryption is a type of utility software and is often used when transferring data on a wireless connection, as they are less secure than wired connections. The data is more likely to be intercepted and needs protection. The original data, known as plaintext, is converted to scrambled ciphertext using an encryption key. At the correct destination, a decryption key converts the ciphertext back into plaintext that users on the receiving device can understand. Encryption can be used with all types of data, including images and web pages, and is especially important for usernames and passwords. Encryption does not stop data interception, but it makes it harder for attackers to understand the data. It can also be used for local storage as well. An IP address identifies a device's logical location on a network. It is used by routers to route data across the internet and ensure that information reaches the correct network. IP stands for Internet Protocol. There are two versions of IP that you need to know. IP version 4 uses 32-bit addresses, allowing for just under 4.3 billion unique IP addresses. However, as the internet grew rapidly, these addresses began to run out, so they invented IP version 6, which uses 128-bit addresses, allowing for 340 undecillion possible addresses. You do not need to memorize these numbers. IP version 4 uses a 32-bit address, represented in Denary. It has 4 8-bit segments of Denary values, from 0 to 255, separated by full stops. IP version 6 uses 128-bit addresses, represented in hexadecimal. It has 8 16-bit segments of 4 hexadecimal values, from 0000 to FFFF, separated by colons. A MAC address is a unique physical address assigned to each device's network interface controller, or network interface card. It is used by a switch to identify and communicate with devices on a local area network. MAC stands for Media Access Control. A MAC address is a 48-bit address made up of 6 8-bit hexadecimal pairs, from 00 to FF, each of these separated by dashes, or sometimes colons. A protocol is a set of rules that allow computers to communicate and exchange data with each other across networks such as the Internet. There are many different protocols used on the Internet, which allow users to exchange data, view web pages, transfer files, and send and receive emails. Each of these protocols will be explained in the next video. Network rules such as protocols must be standardized across all devices on a network to ensure they follow the same rules and interpret data and signals in the same way, regardless of the manufacturer. Standards ensure efficient and compatible communication between devices and are used in all areas of networking, including Wi-Fi, Bluetooth, web browsers, and setting transmission speeds, although you do not need to know any individual standards. TCP/IP reliably exchanges data between devices on the Internet. TCP breaks data down into packets and ensures they are reordered correctly. IP handles addressing and routing the data to the correct destination. A web browser uses HTTP to request and access a web page from a web server. HTTPS is a more secure version that uses encryption for greater protection against data interception. FTP is used to transfer files across a network. It is most often used to upload and download files between clients and a server. SMTP is used to send emails to email servers and between email servers. POP is used to retrieve and store emails from an email server onto a computer. Emails are deleted from the email server once they have been downloaded onto a device. IMAP also retrieves and stores emails from an email server to a computer. The difference between POP and IMAP is that IMAP will save the emails and synchronize them on the email server so they can be accessed by multiple devices. Some protocols like TCP/IP use layers. Each layer has a specific function, making it easier to develop, update, or fix individual layers without affecting the whole protocol. Layers are self-contained, meaning a developer can take a layer out and edit it without affecting other layers. Layers simplify the design of a protocol for developers. Finally, each layer uses specific protocols, so layering ensures these protocols are applied in the correct order. You do not need to know the names of any layers nor their purposes for the J277 GCSE specification. Malware is a category of software with malicious intent, such as causing disruption, damaging a user's system, or stealing personal information. The J277 specification lists malware, but doesn't mention any specific types. The 7 in this video are the most common forms of malware, which are good to know for generally staying safe online. A virus attaches itself to files or programs and spreads when the file is run, potentially damaging or deleting data. It usually requires user action to activate, like opening a file or launching a program. Worms self-replicate and spread across networks without user interaction, consuming a lot of bandwidth and slowing networks down. Worms can also be used to modify or delete data. A Trojan disguises itself as legitimate software to trick people into downloading it. Once installed, Trojans can create a backdoor, giving hackers remote access to the victim's system. Spyware secretly collects user information, such as passwords or browsing habits. It often runs in the background and can be difficult to detect. Keyloggers are a type of spyware that tracks key presses. Ransomware locks files on a computer system using encryption so that a user can no longer access them. The attacker demands money from the victim to decrypt the data. A rootkit hides its presence on a computer by secretly altering the operating system. It gives attackers unauthorized access to the system remotely and without detection, making it hard to identify and remove. Finally, adware automatically displays or downloads adverts onto a device without consent. It can slow systems down and be intrusive, sometimes even tracking user activity. Protection measures against malware include anti-malware software to detect and remove harmful files, a firewall to monitor network traffic and block suspicious connections, and user access levels to restrict what users can download, install, and run. Social engineering is a method of tricking victims into giving personal data or access to systems by pretending to be somebody they know or an organization that they trust. Phishing scams are used to collect data or trick users into installing malware. Humans are often the weak point of network security. As well as falling victim to social engineering, people may have weak or reused passwords, click on malicious links, write passwords down, or not cover passcodes when entering them. To protect against social engineering, user education is important so staff know the signs of a phishing scam. Also, spam filters can detect phishing emails and block them from being opened. Finally, a firewall can block a malicious URL from being opened. Brute force is a trial and error method of cracking a password by trying a large number of combinations in order to eventually enter the correct one. Automated software may be used to try all combinations, starting with common passwords. Protection against brute force attacks includes using strong passwords that won't quickly be guessed by automated software. Account lockouts after 3 attempts could be used to ensure that attackers can't guess forever. And finally, two-factor authentication may be used, requiring a password and a separate code. A denial-of-service attack floods a web server with a large volume of traffic simultaneously, overloading it and causing it to fail. A distributed denial-of-service attack, or DDoS attack, uses multiple systems, often a botnet, to transmit data. To protect against a DOS or DDoS attack, a firewall can filter out malicious traffic to prevent the server from being overloaded. Also, load balancers can distribute traffic across multiple servers. Finally, a proxy server can filter malicious traffic and hide the server's IP address. Interception is the unauthorized access of data while it's being transmitted across a network, often using a tool known as a packet sniffer. If the data is not encrypted, it can be read and exploited by attackers. To protect against data interception and theft, encryption should be used to scramble data into an unreadable format during transmission. A firewall can block unauthorized access to a network, and physical security can be used to prevent data from being stolen in person. An SQL injection is when a malicious SQL query is entered into a website's input box. It may exploit security flaws and give unauthorized access to its database. It can allow attackers to view and modify data or gain administrative privileges. To protect against SQL injections, input validation or input sanitization should be used to spot and remove SQL commands. User access levels should limit privileges to minimize potential damage. Finally, penetration testing can identify insecure websites so they can be better protected. Penetration tests assess the security of a system or network. They identify vulnerabilities or weaknesses so they can be fixed before malicious hackers can exploit them. Penetration testing can protect against unauthorized access, SQL injections, and brute force attacks. Antivirus software scans files and programs and compares each to a database of known malware signatures. It can quarantine, block, and remove suspicious files to prevent them from harming the system. Anti-malware can protect against all types of malware, including viruses, worms, trojans, spyware, and ransomware. A firewall monitors and controls incoming and outgoing network traffic. It acts as a barrier between an internal network and external networks like the internet. It blocks unauthorized access while allowing safe data to pass through. A firewall can protect against unauthorized access, malware, and DOS or DDoS attacks. User access levels control what users can see and do on a system or network. Users may be given different permissions. This helps prevent accidental or intentional misuse of data and keeps sensitive information secure. User access levels can protect against unauthorized access, SQL injections, and malware. Strong passwords are important for network security as they make it harder for attackers to guess or crack login credentials using attacks like brute force. This helps prevent unauthorized access to systems, data, and user accounts. So strong passwords can protect against brute force attacks, unauthorized access, and data theft. Encryption is the process of scrambling data using a key into an unreadable format so that attackers cannot understand it if intercepted during transmission. Encryption can protect against data interception and data theft. Physical security can restrict access to systems and network hardware. Security can include locks, keycards, cameras, biometric controls, and staff to secure server rooms and prevent unauthorized access and data theft. An operating system is software that helps to manage the resources of a computer, especially managing memory, peripherals, users, and files. It also provides the interface between the user and the computer's hardware. An operating system provides a user interface by displaying output and allowing users to interact with the computer through inputs, most commonly through a graphical user interface. Alternatively, a command prompt interface is entirely text-based and allows users to interact with the operating system by typing commands. It provides direct control over files, system settings, and network tools, but requires knowledge of specific commands. The operating system manages memory by ensuring each program has enough space to run without interfering with other processes. It manages virtual memory if RAM becomes too full. Look back at 1.2.1 for more information about virtual memory. The operating system moves data from secondary storage to RAM, so it's available during the fetch-execute cycle. The operating system also enables multitasking by tracking active programs and giving each one access to the memory it needs when required. The operating system manages how data is transferred between peripherals, the fancy word for external devices, and the central processing unit. This allows communication between a computer and connected devices like keyboards, mice, and printers. Peripheral communication requires software called a device driver. Each driver translates the operating system's instructions into specific commands the device can understand. Drivers are operating system dependent, meaning you would need a different driver for a Windows operating system, a different one for Mac OS, and a different one for Linux. The operating system manages users by creating individual user accounts, each with specific permissions, such as an admin or a guest, and it manages security settings, like changing a password. Finally, the operating system manages files by allowing them to be named, moved, copied, deleted, allocated to a folder, opened, saved, and much more. It can also manage permissions, so certain files can only be accessed by authorized accounts. Utility software performs a specific task and is related to the maintenance and optimization of the computer system. This is known as housekeeping. There are many different types of utility software, including anti-malware, firewall, backup, and device drivers. The J277 specification only lists encryption, defragmentation, and compression as the three you need to know. Encryption is the process of scrambling data into an unreadable format using a key, so that attackers cannot understand it if intercepted during transmission. See 1.4.2 for more information about encryption. Over time, files on a hard drive will be split and stored in separate locations on the disk. This slows file access down as the read-write head will have further to physically move to access the next part of the file. Defragmentation software reorders files so that each part is stored consecutively, improving data access speeds as the read-write head has less distance to move. It also orders all three spaced together so that new files won't be fragmented. Compression is the use of an algorithm to reduce the size of a file. Compressed files take up less storage space, so more files can be stored, and they are faster to transfer across networks. For more information about compression, see 1.2.5. The increasing use of computer systems and digital technology, such as the internet, has introduced a range of ethical, legal, cultural, environmental, and privacy issues. This video looks at 16 different impacts across the 5 different categories. Firstly, the digital divide refers to unequal access to technology, which creates gaps in education, work opportunities, and social connections. Technology has affected work and education too, enabling flexible remote working and online learning, but blurring the boundary between work and life. Governments can use surveillance to monitor activity and keep the public safe, but this raises questions about freedom and online privacy. Online tools like social media and gaming have enabled new forms of cyberbullying that can be anonymous, constant, and emotionally harmful. Long-term computer use can affect physical health, causing poor posture, eye strain, and mental fatigue. Late-night smartphone use can disrupt sleep. Constantly manufacturing new devices consumes energy and raw materials, contributing to pollution and carbon emissions. Old devices often end up in landfills, creating harmful e-waste and pollution. Computers are difficult to recycle due to the mix of materials inside of them. AI can boost efficiency, but automation may replace human jobs and raises concerns about fairness and accountability. Planned redundancy, such as releasing a new smartphone every year, leads to increased electronic waste and resource consumption. Similarly, peer pressure to buy the latest devices encourages unnecessary upgrades, contributing to e-waste and more unsustainable consumption. Some governments and platforms restrict or censor online content, limiting freedom of expression or promoting a certain political agenda. AI systems can reflect human bias if trained on unfair data, leading to discrimination in areas like hiring or surveillance. Personal data is constantly collected online, raising ethical concerns about consent, tracking, and surveillance, especially if that data is stolen. Excessive use of technology, such as social media or video games, can lead to addiction, impacting productivity, social skills, and mental well-being. Technology makes it easier to create and share content, but also raises challenges with copyright, plagiarism, and legal ownership of digital content. Finally, self-driving or autonomous cars could be safer and more convenient, but they also raise ethical questions about blame if an accident was to occur. The Data Protection Act, which was last updated in 2018, protects the personal data of individuals, ensuring organizations collect, process, and store it responsibly. Each person who has their data stored about them is known as a data subject. An organization must appoint a data controller, responsible for how personal data is collected and used, and must register with the Information Commissioner's Office. The Information Commissioner oversees and enforces several laws in the UK, primarily the Data Protection Act. There are 6 principles of the Data Protection Act. Data must be collected lawfully and processed fairly. The data must only be used for the reasons specified. The data must be relevant and not excessive. The data must be accurate and up to date. The data must be stored for no longer than is necessary. And the data must be stored and processed securely. The Computer Misuse Act, which was introduced in 1990, aims to prevent and punish the improper use of computers. Violating this act can result in fines and multiple years in prison, depending on the severity of the offence and whether it was intentional or not. There are 3 principles of the Computer Misuse Act. The first is that there should be no unauthorized access to computer systems or data. As an example, hacking would break this principle. The second principle is that there should be no unauthorized access to data with intent for further illegal activities. for example, accessing personal data to then use in blackmail or identity theft. The third principle is that there should be no unauthorized modification of data, for example, spreading a virus to corrupt or change data on a system. The Copyright Designs and Patents Act of 1988 makes it a criminal offense to copy work that is not your own, without the permission of the creator or copyright holder. This act gives creators rights to their work and the freedom to control how others can copy, edit, and distribute it. Copyrights can be applied to text, images, music, videos, and software. The Copyright Designs and Patents Act prohibits these actions: importing and downloading illegally copied material, possessing equipment used to copy copyrighted material, making copies of copyrighted material to sell to others, distributing enough copyrighted material to have a noticeable effect on the copyright holder. Some of the actions that you can take to abide by the Copyright Designs and Patents Act are asking the permission of the copyright owner before using the material, using material marked as copyright-free, for example with a Creative Commons license, and finally purchasing a license to use the copyrighted material. Software is protected by copyright laws and may require a license to use. There are two main types of software licenses which relate to source code. This is the high-level code written by the software developer. The two license types are open source license and proprietary license. With an open source license, access is provided to the source code for the user to see and edit. Examples of open source software include Linux, Firefox, and VLC Media Player. The advantages of an open source license include that because the source code is accessible to edit, it can be customized to a user's needs. Also, unwanted features can be removed to make the software smaller in size and run faster. Open source software is often shared online, so users can work together to modify, debug, and improve it. Finally, open source software is often low in price and may even be free. The disadvantages of an open source license include that there are security risks, as an editor may add malicious code to the program. The code could also contain errors, as it may not be fully tested. Support can be limited, as projects are often maintained by volunteers who may stop contributing. Finally, it actually requires the programming skills necessary to understand and edit the source code efficiently. With a proprietary license, there is no access to the source code for the user to see or edit. The software is usually purchased. This is known as off-the-shelf. Examples include video games and Microsoft Office applications like Word and Excel. The advantages of a proprietary license include that the code should be well tested, and it may have updates and bug fixes to be even more secure. The company can be held to account if it does not perform as listed in the terms and conditions upon purchase. Also, most developers will provide some sort of help and support. Finally, developers can sell licenses, generating profit from their work. The disadvantages of a proprietary license include that users must rely on the developer to provide updates and fix issues. This might be infrequent or stop completely. It is often not free. Users must pay the developer who owns the copyright for a license to use the software. Also, users cannot see the source code, and so they cannot modify it, debug it, or improve it for their own benefit. Finally, developers miss out on community contributions that could improve the code or remove errors.